Okay, so what I'd like to do is get into the operations of functions. So I'm going to knock out another homework assignment, and what I plan to do, I've been kind of out of the classroom for the last couple of days, so in this live stream also, well, not in this live stream, but after this, I'm actually going to get into inverses of functions. So if that's something you're interested in as well, I'll break up the two streams. But what I want to cover today is in this homework is just kind of work on different operations of functions, adding, dividing, subtracting, division, as well as composition. And really when we're applying the operations, we're going to be focused on kind of talking about the domain and then also looking into evaluating, finding the value of the functions. I'm also going to talk about being able to determine even and odd functions, and then we'll look into some multiple choice type questions for this. Now, in my class, I worked on, showing the students a lot of different variations of functions that we can apply operations to. And for this homework assignment, I'm going to keep things rather kind of simple. And you can see here, we don't have any restrictions on our domain. So, in class, we talked a lot about looking at the restrictions and how that impacts the different operations. But for the homework, I'm kind of keeping things simple. So if you want some of those, just look through obviously my collection of content, and you'll be able to see a little bit more kind of difficult examples. But without further ado, I want to kind of get into this, just kind of make sure that I have everything. Hey, Fab. Good to see you. What topic is this? We're talking about, oops, I lost my thing. There you go. We are talking about functions, and we are talking about not just functions, but operations of functions. So basically, we're going to multiply, divide, I don't think I did, and compose. So that's at least what I'm doing in this case. Just going to cover some of the operations. You could also work on adding and subtracting, but for the homework, just try to keep things basic. Make sure students can apply some basic operations. So let's go ahead and get into it. And then one thing I also mentioned to you guys, hey, Tedenda, sorry about that if I messed up your name. Even my students, I'm messing up their name all the time. But anyways, I want to let you guys know if you do have some questions, let me know. I will plan on taking a break after I finish the first page and just kind of check in with you guys. And then if you do have some questions though you'd like me to cover at the end of the live stream, I'll be more than happy to kind of see what I can do to helping you guys out that stay with the stream for on that. So again, the name of it is operations of functions. Okay, so we're dealing with functions and then operations of functions. Let's actually use a violet color. All right, so in the first example, I think I just talked about applying the operation and then determining the domain. So in this case, I have f of x and g of x. So if I'm going to look into, you can see here is f times g of x. So basically, that is the same thing as f of x, zoom in a little bit, times g of x. Okay, so basically, I'm just going to take the f of x function, 2x plus 1, and then multiply it times the g of x function, x squared minus 3x. Okay, and then obviously, guys, if I need to multiply this, I can just use the distributive property. You could think of FOIL since it's two binomials. So 2x times x squared is going to be a 2x cubed. 2x times negative 3x is going to be a negative 6x squared. Oh, these actually does combine. X squared times 1 is going to be a positive x squared. And then 1 times negative 3 is going to be a negative 3x. And now I can combine my like terms here. And therefore, this is going to give me 2x cubed. This becomes a negative 5x squared minus 3x. So if I'm looking into identifying the domain here, notice the domain of these two functions are unrestricted. This is negative, I don't want to use purple. Let's use green. Notice that this function is a line. Is a line. So therefore, the domain is from negative infinity to infinity. And this is a quadratic, so again, this domain is unrestricted from negative infinity to infinity. So just because I'm multiplying the two functions, you're going to basically find the intersection of the two domains. Well, since they're both all real numbers, this domain is also going to be all real numbers. All right, now, oh, and then also then the next one is multiplying g times f and then of 0. So there's a couple different ways we could do this. You could apply the product like we did and then evaluate for 0. Or what you could also do is, let's do pink. What you could also do is just do g of 0 times f of 0. And I kind of like that process a little bit better in this case because, you know, these are rather simple that g of 0 is basically going to be 0 squared minus 3 times 0. And then if you just notice, this is 0, right? 0 times anything, I'll just write it out still, but 0 times anything is going to be 0. So therefore, g of 0 times f of 0 is just equal to 0. Okay, so that's not always the case, and you'll see that not always it's going to be 1, you know, or whatever you're evaluating for, but in this case, it's just equal to 0. All right, let's see. All right, so now let's go and work into division. So real quick, actually, to recap, one thing we talked about in class was that when you're applying the operations, and I only did multiplication here, but when we apply the operations of addition, subtraction, and multiplication, you are combining the two domains. So if you do have functions that are restricted, you got to make sure that you combine them with the other domain of the other function, and make sure you're finding the intersection of where their domains are, you know, the same. So just make sure you understand that as we, you know, kind of get for addition, subtraction, and multiplication. All right, now working into division. Now division is a little bit different because division, now what you're doing is you're taking a function and placing it in the denominator, where now we have that restriction of you cannot divide by 0. So when we take f of x, or f divided by g of x, again, that is really just saying f of x divided by g of x. And so even though g of x has a domain of all real numbers, let me write it out there. Even though g of x has a domain of all real numbers, this presents a problem for us here because it's now in the denominator. And if you remember when we talked about the restrictions of the domain in the denominator, we know that it can't equal to 0. So even though the function is all real numbers, we now have to check out and say, uh-oh, well, x squared minus 3x cannot equal 0. So let's find the values that make it equal to 0. Well, in this case, from here, we have basically a quadratic that now we can just factor out an x. So we have x times x minus 3. And now we can use the 0 product property. So x is equal to 0 and x minus 3 is equal to 0. Add 3 to both sides, so x equals 3. And hopefully what you guys can see is when x is equal to 0 or when x is equal to 3, the denominator is going to be 0. So if I wanted to identify the domain here, I'll use it in green. Where'd you go? So the domain in this case is going to be all real numbers except for 0 and 3. So if we looked at a number line real quick, let's just do a number line. At 0 and 3 are the only values that are not in the domain. Everything else is covered. So therefore we'd write the domain like this. Negative infinity to 0, union 0 to 3, union 3 to infinity. Okay, that's how we'd write basically that domain for all real numbers except for 3 and 0. All right. Now the next one is basically taking us for what is g of 1 over f of 1. And this kind of goes back into the other one. You could plug in, you could do this as g of 1 over f of 1, you know, or you could basically just evaluate for g of x over f of x and then plug in the 1. And it doesn't really matter which way you do it. So let's just do the plugging in g of 1 over f of 1 since I already have that kind of written out. So therefore that'd be 1 squared minus 3 times 1 over f of 1, which would be 2 times 1 plus 1. And let's do a little simplifying here. So 1 squared is 1 minus 3, so that's going to be a negative 2. And then 2 times 1 is 2, plus 1 is going to be 3. So therefore you can see that g of f, or g divided by f of 1 is a negative 2/3. All right, the next one is composition. So man, I did it both ways, and then I have an evaluate one. Sweet. All right, so remember composition is basically plugging one function into the other. And when we're identifying the domain of composition, basically we need to keep in understanding that you're going to keep the domain of the function that you're plugging into the other function, as well as finding the domain of once you have completed the composition and once you've plugged the other function into the single function. Now, in this case, I'm not really asking my students to worry about that because the two functions that I decided to do have domains for all real numbers. So we're not going to have to worry about the domain being restricted, but I really want them to practice plugging one function into the other and then simplifying. So let's go and take a look at this first example. So f of g of x, I think I wrote that wrong, I did. That should have a second parentheses. Oh, I messed that up. Man, I messed that up. It should look like this. F of g of x. There you go. That's how it's supposed to look. I don't know what happened there. This is supposed to be g of f of x. And that's wrong too. G of f of negative 1. Okay, and that's really important though because, you know, when we have f of x is equal to 2x plus 1. If I say evaluate for f of 1, then you replace the x variable with a 1. So if I say find f of g of x, which I got to have those parentheses correct, that means you're going to replace the g of x with that, or the x with the g of x. And now the thing is though, it looks confusing, but it's the same process as what we did up here with the 1. Now the only difference is though, we have g of x defined. G of x is x squared minus 3x. So let's actually simplify this. So we have 2 times x squared minus 3x plus 1. So now you can see to get my final answer, all I need to do is distribute the 2's. 2x squared minus 6x plus 1. And there we go, we're done. So therefore now if I'm going to do g of f of x, basically what I'm asking you to do now is again plug the f of x function into the g of x function. So by plugging the f of x into the g of x function, I basically have the g of x function, which is, so it's going to look like this, f of x squared minus 3 times f of x. And again, we know what f of x is because f of x is 2x plus 1. So I have 2x plus 1 squared minus 3 times 2x plus 1. Okay, so now I can expand this. Now I'm not going to work this out for time purposes, so I'm going to expand 2x squared plus 1 squared. So therefore, let's see, that's going to be 4x squared. 2x times 2x is 4x plus 1. And then now apply distributive property here. So I have negative 6x minus 3. I'm not sure why I'm using parentheses there. Okay, and now it's basically just going to be combining like terms. So we have 4x squared, and then we have 4x minus 6x, which is a negative 2x, and then 1 minus 3, which is a negative 2. Okay, that's a really bad 2, but there you go, maybe. All right, and I forgot to kind of mention the domain. Well, either way, guys, once you do the composition, again, it's really important for you to understand the domain of the function you're plugging into. Make sure you take that into account. And then as well as once you have evaluated or once you plug the function into the other function. Well, again, in this case, g of x is unrestricted and my simplified version here is unrestricted. So the domain is from negative infinity to infinity. And again, over here, f of x is unrestricted, so we don't need to worry about that domain. And this domain is another quadratic, so my domain is negative infinity to infinity. And then the last one is just evaluating for f of negative 1. Now again, if we know this is really saying g of f of negative 1. So let's figure out what f of 1 is. So f of x is, what, 2x plus 1? 2x plus 1. So that means f of negative 1 is 2 times negative 1 plus 1, which is negative 1. So if I want to figure out what is g of f of negative 1, Well, I already know what f of negative 1 is. F of negative 1 is equal to negative 1. So isn't that really the same thing as g of negative 1? Yeah. So g of x is x squared minus 3x. So that means g of negative 1 is going to be negative 1 squared minus 3 times negative 1, which is 1 plus 3, which is equal to 4. So therefore, this answer here is 4. All right, last one that I want to talk about is the even and odd. So this is something that we talked about in the previous example, but we really kind of focused on the graphs. And I really didn't want to talk about this until we had talked about evaluating functions and finding the value of the function. So obviously in the notes I go over this in a little bit more detail as far as when functions are odd or even, or why that makes sense. I've also kind of talked that about in my notes. So I'm not going to cover that in depth on this one, but what I will do is at least kind of go over the rules that you need to follow. And the basic rules is fairly simple. To evaluate if a function is even, plug in f of negative x. And if you get back the original function, then it's even. And to determine if it's odd, plug in f of negative x. So the same thing, same rule. But if you get opposite of f of x, then it's odd. And if you get anything outside of f of x or opposite of f of x, then guess what? It's neither odd nor even. Okay? So that's basically like the rules. It's fairly simple, but there are obviously some that can get a little bit more difficult. So let's just kind of work through it and kind of see how that works and explain it. And then obviously if you're more interested to see like why that works or why that makes sense, in my guided notes I kind of talk about it. But all right, so just to evaluate for f of negative x, and again, a student asked, could you use like negative 1 or something? Like, yeah, you could really use any number you want to, because it doesn't matter. If odd functions are reflective about the origin, and even functions are reflective about the y-axis. So anyways, let's plug in a negative x squared times 1 minus negative x squared. Now, what's really nice about doing these examples is really remembering that a negative expression raised to an even power is going to be always positive. So this turns into be x squared. And then 1 minus the negative x squared. Now again, you got to be careful though. Negative x squared is x squared. So we still have, so inside this is now turned to a positive x squared, but you're still subtracting that positive x squared. And what I want you to notice is after plugging in a negative x, I have back my original function. So therefore this is even. All right. The next one. Let's plug in g of negative x. So when I do that, I get 2 times negative x to the 5th minus 4 times negative x cubed plus 6 times negative x. Okay, now again, anytime you had a negative term raised to an even power, it was positive. Anytime you have a negative expression raised to an odd power, it's going to be negative. So negative x to the 5th times 2 is a negative 2x to the 5th. A negative x cubed is negative x cubed. Negative x cubed times negative 4 is going to be a positive 4x cubed. And then negative x times 6 is going to be a negative 6x. Okay? Now, sometimes you might see that this is opposite, positive, negative, negative, positive, positive, negative. What I like to do is represent it by factoring out a negative. So therefore, you'd have 2x to the 5th minus 4x cubed plus 6x. And now what you can see is this right here is f of x, and that's being multiplied by a negative. So you're taking the opposite of the function. So therefore, this is an odd function. All right. And the last one, guys, is looking at the g of x. So we're going to do this g of x again, doing the same process here. G of negative x. So then you plug in a negative, x squared minus 5 times negative x all over a negative x cubed plus 1. Okay, and when we simplify this, that turns to a positive 3x squared. Negative x times negative 5 is a positive 5x, and that turns to a negative. And you can see that they don't all have the opposite signs. Like these are the opposite signs, but those are not the opposite signs. And it's not exactly the same. So this is an example of neither odd nor even. And kind of a little tip and something to check out. When you have like powers that are one's even and one's odd, it's never going to be the same even or odd. Okay, there's a little tips and tricks to like look at it. But, just a kind of general rule of thumb, whenever you see at least the powers are different, odd and even, then it's not going to matter. And then notice also this one's odd, but notice all the coefficients are even. So it's not about the coefficients. It's about the powers. But again, well, I guess not always, and then really be the case. But either way, that some of these can be tricky, so you don't want to be careful. But when you're dealing with polynomials, look at the powers, not anything else. All right, I am going to take a quick little break before I get to the multiple choice, just to kind of see who else is kind of hanging in here. See if you got, hey Alta, hey Beauty School, and hey Alta and Brandon. Just wanted to say hi to you guys. Brandon, good for you taking calc. I really miss teaching calc right now. I'm teaching only pre-calculus, and I'm kind of crazy right now. I've been gone. I was out the last 2 days, so today I had to teach like 2 lessons. So I just told my students, hey, I'm going to be doing direct instruction all day. So this is what I've been teaching is operations functions and inverse of functions. And then I was like, crap, I got to do a live stream today too over operations of functions and inverses of functions. So I'm kind of a little burnt out on this topic. So hence, sorry if I'm not as enthusiastic. And then I got to teach this again on Monday. So I really do miss having calculus to like break up the teaching and not just teaching pre-calculus. But hey, it is what it is. I do have, still a lot of calculus videos, and I want to keep on making some more calculus videos, but I just don't know. I'm really, really working on creating a lot of my resources and making them available, for students that are, part of my extra kind of groups on Patreon or on the sponsorship that really want access to my materials. So I've really been like working on that. And then also it's not just for them, it's for my own students. So I mean, it's stuff that I'm creating inside of my class. And, so I have it available for my students, and some of the stuff I've already made and I've reused, but a lot of stuff I'm still making it, every week. So every week I'm always, working up late at night, working on, creating their homework and their investigations, guided notes. I'm about halfway through the course right now. So I still got quite a bit to go, but I am just a reminder, guys, if you are interested in anything on inverses of functions, I am going to probably work this live stream. Probably got about like 10 minutes left here, maybe not even, maybe 5 minutes. And then I think what I'm going to do is take like a 15-minute break and then come back at like 3:45 and do inverses of functions. So if you are interested or if you have any questions, let me know, and then I will be more than happy to answer any way I can. All right, so let's go and get into multiple choice. So just a couple multiple choice questions, that we want to kind of discuss here. What to work with them and how to do them. So again, this is asking, is the function odd or even, or, failing. Well, let's see if even or odd kind of works here. So first thing I'm going to do is I'm going to plug in f of negative x. And when plugging in f of negative x, I get negative x all over negative x squared minus 1. And therefore I have a negative x all over x squared minus 1. Now, again, if you can like factor out this negative here, factor out that negative, you're going to get, so the negative is up here in the top. So I have an x all over a x squared minus 1. And you can see here that negative, so you can see by factoring that negative out, because again, guys, remember, it doesn't matter if the negative is in the numerator or if the negative is in the denominator. It'd still be the exact same thing, right? Negative 4 divided by 2 is the same thing as 4 divided by negative 2. So it doesn't matter if I have this negative in the numerator or denominator, but if I factor this out, you can see that we have exactly the opposite function here, which in this case is going to be odd. All right. Neither even or odd, not defined at 0. The function is defined at 0. and not defined, it doesn't fail a vertical line test, so it is a function. So here the answer is B, which is odd. All right, next example, we have f of x equals 3x squared minus x, and g of x equals x plus 1. Find and simplify the composition. So again, remember, we're just going to take the g of x, and we're going to plug it into f of x. So I might be running out of a little space here, but we'll see how good I can do here. So f of g of x basically is going to be my f of x function. And let's go ahead and plug in g of x. So that'd be 3 times g of x, which is x plus 1, squared minus x plus 1. Okay, so x plus 1, I can expand that. Hopefully you can follow me here. X squared plus 2x plus 1. And remember, that's all multiplied by 3. And then here I can also distribute the negative. All right, let's distribute this 3 here. So therefore, I'd have a 3x squared plus 6x plus 3 minus x minus 1. And then let's do this 3x squared. 6x minus x is going to be a positive 5x. 3 minus 1 is a positive 2. And let's go and see. It looks like we have answer B again. Cool. This example is just evaluating for f of negative 4. So that basically I'm just going to plug in negative 4 in for every single time I see an x. So, and we have to follow a little order of operations here. That's kind of nice. So I'm going to put parentheses around this so I don't make the mistake of some operations. So negative 4 minus 2. And you can see every single time I plugged in I placed an x with a negative 4. Because I'm putting parentheses around them. And that's cubed minus 36. All right, so negative 4 minus 2 is going to be negative 6. Negative 6 squared is 36. Negative 4 plus 5 is 1. 1 cubed is 1, and then minus 36. And it looks like I'm getting the answer of 1. So there's my answer 1. All right, last but not least, this one says if f of t equals square root of t plus 8 and g of u equals 2u minus 1, then what is the rule defining the function h of t, where that is the g of f of t? So again, g of f of t is equal to g of f of t. So basically what I'm going to do is I'm going to take the g of x function and plug in f of t. So g of u here is equal to 2u minus 1. And if I'm going to replace u with my f of t, then basically it's just going to be, let's put there. So therefore I'm going to plug f into g. Okay, so that's going to be 2 times the square root of t plus 8, and then minus 1. And now you can distribute that if that happens. Doesn't look like my answer is there. So therefore I can distribute this. 2 square root of t plus 16 minus 1. And now I can see my answer, 2 square root of t plus 15. And therefore that's going to be answer E. Now, since I didn't cover a lot on the domain, I did have some nice little challenge problems. You know, if you are kind of looking into identifying, the domain and looking at the restrictions when you apply compositions or adding and subtracting, these are some cool ones, and then obviously a little fun one here as well. So, but that kind of covers at least the basics, I think, of just understanding compositions, adding, subtracting, and even and odd functions. Hopefully that has helped you out. And then, again, if you guys are interested, I will be doing another live stream here in about 15 minutes covering inverses of operations. So do you think the public would have access to your material soon? Oh, Brandon Sauce again. No, I'm not sure that I'm going to be offering. I mean, some of the material I do have, like I'm working on creating some of my content that is going to be available that I can add into videos, because one of the things I asked, students was, they wanted to have some videos that were, or have like some resources that were helpful with them. So I do have some of that content that I am going to make available that everybody can use. It will kind of be like after a video or during a video, you can use it as like a cheat sheet or quizzes and stuff like that. So I will be doing that. As far as like the content I'm creating for my class, I'm not making that available for the public yet, just because I'm not finalized. It's not finalized yet. So basically, I'm doing a process where I'm creating all the content now, and then obviously, providing that for people that want kind of early access to the information. And then what I'll look into doing is refining all of that again, and then kind of having that package together in certain packages for people that are looking into it. But it is taking like a little bit of process. It's it costs a lot of money to hire an editor and people to reviewer. And all those kind of things, because right now it's just me all by myself. So, I'm spending all the time creating it. And then also I'm hiring people to help format it, help review it, help edit it. So as of right now, I'm only able to really support the kind of paid version. But I will tell you that I will, have some of that stuff available for, free, and just to help you guys out as much as I can. But for a lot of the stuff I want to create, it takes a lot of time and money to get it done. So that's what I'm basically kind of working on now. But I will have some more stuff available for you guys. Thanks, Sebastian. Glad you could join the stream. Cheers. All right, guys. Well, I'm going to go ahead and pull this out and work on relaxing here, and then I'll be back for the next one. Cheers. Bye.